Hello guys. Today we are starting by our new chapter 3 of Science Class 7 CBSE Element Compounds and Chemical Equations. हम एक क्वेश्चंस भी फॉर्म करेंगे, खुद से बैक एक्सरसाइज भी डिस्कस करेंगे और उसके साथ साथ चैप्टर की रीडिंग भी करेंगे. So let's start. In our everyday life, we often make objects by joining basic building blocks together. For example, with a set of plastic building blocks, many different modules can be made. Similarly, all living and non-living matter on Earth is made of some basic components. What is an atom? There are millions of substances in the world. However, they are all made from a basic building block. The basic building block of all matter is atom. Everything in this world is made up of atom. Atoms are the tiny invisible particles that have the characteristics properties of a substance. The term atom is derived from a Greek word atoms that means invisible. Elements. At Laurent Lavoisier is a French chemist which was the first to establish the useful definition of an element. An element was defined as basic form of matter which cannot be broken into simpler substance by chemical reactions. An element contains only one type of atom which have the same properties. For example, a lump of sodium contains just sodium atoms which have the same mass and chemical properties, while pure gold consists of some gold atoms. Atoms of different elements have different masses and chemical properties. Currently, 118 elements are known to exist, out of which 98 are naturally occurring in the Earth's crust, while the remaining have been prepared in laboratories. Aluminium, copper, zinc, hydrogen, oxygen, nitrogen, potassium, and sodium are some of the elements. Oxygen is the most abundant element on Earth's crust. Unlike gold, platinum, and silver, which are less reactive and occur in free state on the Earth's crust, most elements combine with each other element and form a compound. The elements which occur naturally in the form of compound are found deep under the surface of Earth are called minerals. Out of all the minerals of the metal, only few are as sources to extract metals. Such sources are called ores. For example, Kinabara is the ore of mercury, Hanamatit is the ore of iron, Bauxite is the ore of aluminium, and Galena is the ore of lead. Chemical symbols. The elements are known as exist have been given chemical symbols to avoid confusion. केमिकल सिंबल का पूरा पार्ट जो है कट हो चुका है, ये पूरा कट हो चुका है, तो हम यहाँ स्टार्ट करेंगे. Many elements have the symbol which is ये है. The following are certain rules which are followed to assign a symbol to any element. First, many elements have a symbol which is a full letter of its name in English. The symbol is always written as capital letters. For example, the symbol of hydrogen is H, carbon is C, boron is B, oxygen is O, nitrogen is N, etc. When there are more than one element that begins with same letters, their symbols take two letters of element's name in English. The first letter is capital and the second letter is small letter. For example, the symbol of helium, He, aluminium, Al, cobalt, Ko, calcium, Ka, etc. Symbols of some elements consist of the first letter of the name and a letter which appears later in their name. For example, zinc, Zn, fluorine, Cl, etc. Some elements have been given a symbol which is based on the name of the element in Latin, German, or Greek. For example, sodium is Na from natrium, iron is Fe from ferrous, potassium is K from calcium, etc. Thus, every element has its unique chemical symbol. Molecules. Most atoms are not able to exist independently. As two or more atoms of an element chemically combines together to form molecules. These molecules aggregate in large numbers to form matter that we can see, feel, touch. The atom in a molecule are tightly held together by strong attractive forces. An atom is the smallest unit of matter which can exist independently. So, molecule of element and molecule of compound. Combination of same type of atom, for example, the molecule of a hydrogen gas H consists of two atoms of hydrogen. Similarly, molecules of nitrogen N consist of two atoms of nitrogen. Molecules of compound. Molecules of element, combination of same type of atom. Molecules of compound, combination of atom but different in element. For example, molecule of water H2O consists two hydrogen, one oxygen atom, and molecule of carbon dioxide contain one carbon and two oxygen atoms. Atomicity. A molecule of an element is formed by the combination of the same type of atom. There are certain molecules of element which are made up of just one atom of the element. They are called monomatic molecule. For example, argon, neon. Molecule of nitrogen and 2 consists two atoms, hence are known as diatomic molecule. The molecule of 3 atoms consist of element is called triatomic molecule, and such as ozone. Number of atoms of an element present in a molecule are known as its atomicity. Molecule containing more than 4 atoms of an element is termed as pilomatic molecule. So, name: helium monomatic, oxygen diamatic, hydrogen diamatic, chlorine diamatic, phosphorus pleomatic. Compound. A compound is a substance that is formed by the chemical combination of two or more elements in a fixed proportion. For example, carbon and oxygen. They are both elements, but when we chemically combine, they form compound, such as carbon dioxide. It should be noted that each compound has the same element in the same proportion, regardless of the sources of the compound from where it's obtained. For example, carbon dioxide will contain one carbon atom and two oxygen atoms. Water H2 and ammonia, NH3, calcium oxide, calcium hydroxide are some examples of a compound. An element combines lose their individual property and a new substance is formed, totally different properties. We use table salt, sodium chloride. While cooking, sodium is a silvery solid element which reacts violently with water, while chlorine is a green protrusion gas. When these two elements combine, they form sodium chloride, whose properties differ from its constituents. The constituents of an element can be separated only by chemical reactions. A large amount of heat is required to break the chemical bonds between an element of compound. Mixtures. When two or more substances are put together in any duration and involve no chemical reaction, we obtain a mixture. The substance that make a mixture may be element, compound, or both element and compound. Going back to the introductory activity of the chapter, you will see the F contained mixture of 2 washers, 1 bolt, 1 nut. Then, in a mixture, the components retain either properties even after they're mixed. Salty water is a mixture in which components salt, that is sodium chloride, and water H2O are both compound. These compounds are mixed with the salty water, still has the fluid properties of water and taste of salt. The constituents of a mixture can be easily separated by physical methods, for example, salt and seawater, and be obtained through evaporation. Difference between compound and a mixture. First, mixture. A component of a mixture, that is, element or compound, just mixed in the form of a mixture and no new compound is formed, that it will no chemical bonds. Compound first. Element reacts chemically to form new compound that they are joined by chemical bonds. The components of a mixture have variable composition. The composition of a compound is always fixed. The components of a mixture retain their individual properties. A compound has different properties than the element it has been made from. The compound of a mixture can be separated by using physical means. The components of a compound can be separated by chemical reaction. Then, chemical formulas. Just like chemical symbols of an element, we have chemical formulas of compounds. Chemical formulas are useful as they represent the composition of the compound. Consists of one atom of nitrogen and three atoms of hydrogen cube. For example, chemical formula of ammonia. Of one atom of nitrogen, three atoms of hydrogen. To be able to write formula of compound, we must understand combining capacity of an element. The chemical formula of table soda is NaHCl3 and vinegar is CH3COOH. Valency. The combination capacity of power of an element is known as valency. It is the capacity of an atom of a single element to react and combine with particular numbers of atoms of another element. Suppose hydrogen, it has one hand and oxygen has two hands. If oxygen has to catch hold of nitrogen in such a way that it holds one hydrogen by each hand, how many hydrogen atoms one oxygen atom can hold? One oxygen atom can hold two hydrogen atoms. Thus, we can represent this H2O. Here 2 indicates number of hydrogen atoms by which an oxygen atom. We can say that combining capacity of oxygen is 2. Hence, the valency of oxygen is 2. Thus, the hydrogen is 1. The valencies are some elements are radicals modules with unpaired electrons given below. Firstly, H, hydrogen 1, argon 1, and so H, hydrogen 1, argon 1, Na is sodium 1, then I 1, K 1, calcium 1, Br 1, then Ka, chlorine 1, calcium 2, oxygen 2, zinc 2, magnesium 2, aluminium 3, nitrogen 3, then C4. So there are some valencies. So ammonium 1, hydroxide 1, nitrate 1, bicarbonate 1, carbonate 2, sulfate 2, phosphorate 3. At a chemical formula, steps are followed to write a chemical formula are for the symbol of an constituent element is written. For example, magnesium chloride, carbon dioxide. We will take magnesium chloride. So MgCl. So we second, then the valence is written below each element. Magnesium 2, chlorine 1. Then the valences are interchanged and write the subscription. So interchange like magnesium 1, chlorine 2. Of the valences are divisible by a common number, simplify the number in the subscript, otherwise retain some. Magnesium 1, calcium 2, as so here is right. Omit the valency 1 means 1 common symbol. So MgCl2. Valency 1 is not written. If the element is written without any valency number in a molecule, it means valency is 1. Thus, the compound magnesium chloride and carbon dioxide has a chemical formula, respectively. Let us now try to write a chemical formula of a compound containing radical. Zinc hydroxide, zinc 1, hydroxide 2, interchange, then the formula is like ZnOH2. Formula of zinc hydroxide is ZnOH2 and not ZnOH2. So here is bracket, is not bracket. If the compound contains a radical, it is enclosed with brackets, and the interchange valency is written as subscript outside the bracket. In case the interchange valency is 1, we do not use bracket. For example, the correct chemical formula of potassium hydroxide is KOH, not KOH bracket. Similarly, the correct chemical